I still got my light. So this is the formula we ended with, the last little thing. We are going to learn how to integrate in the integral of x e to the x dx. On the surface, this might look like a easy integral, so we might try use substitution. That's not going to work. We could try a bunch of things. It's not going to work. We could try to simplify it somehow, but there's no good way to simplify that algebraically, so that's not going to work. But we should always be thinking in our head, like, what else can we try? Obviously, partial integration by partial fractions isn't going to work because there's no fractions here. So that's not going to work. So what we need to do is we are going to take this, look at it through this lens, and then translate it into this. That is our big job. And in order to do that, what we need to do is one of these things, well, there's u and u, so that's good. And then it's u and du. So that means we're going to need the derivative of u. And then there is dv, and it becomes v. So we're actually going to need the integral of dv. So we want to look at this and go, which one's easy to take the derivative of? Which one's easy to integrate? In this case, it's kind of interesting in that this one's pretty easy to integrate. Very easy to take the derivative of. And this one's equally easy in both directions because we should remember that the integral of e to the x is e to the x plus c. The derivative of e to the x is just e to the x, so e to the x doesn't change. But I would argue that the integral of x is 1/2 x squared. That's more complicated than the derivative of x, which is just 1. So since we're going to need the derivative of u, I'm going to say that u equals x. Therefore, du equals 1 dx. We don't really need the 1, but just so we can see it, I'm going to put it in there. So if u is x, that means then dv must be e to the x dx. So I'm going to do that in a different color just so we can see it. So I'm going to say dv equals e to the x dx. And I need to get v out of it. So that means I need to integrate it. And if I integrate it, I'm going to get v equals, well, that's nice, e to the x. I should put in the plus c. We're not going to because it's going to come in later on. Remember when we were integrating both sides of an equation, we only put it in one side. And so I'm not going to put it in during the substitution part of this. I'd assume if you did, it would work out just fine, but we don't need to worry about it at this point. So now I have u and v, and I got dv is e to the x dx, so I'm going to now do my substitution, and I'm going to say that this red equation, which is this, is now this blue equation. So it is u, which is x. So this equation is equal to x times v, which is e to the x, minus the integral, of v, which is e to the x, du, which is 1 d to the x. We don't need the 1, so we just say dx. I'm sorry that that's not coming up very clearly right now. Okay, so we're saying that this, our initial expression, is the same as this. So now this is nice because we don't need to integrate the left side. The left side is what it is. We are all set with that. Maybe I'll change my red marker. The left side of this equation is x e to the x minus the integral of e to the x. Well, we talked about that before. You should remember from earlier this year, is e to the x plus c, and that this thing is exactly the same as where we started, which was the integral of x e to the x dx. So that means if we've done everything right, we should be able to take this derivative and get back to that, right? Just that inside part. And I'd like to take the moment to just try that out. I'll interject the final color. We need to remember product rule. So the derivative of x is just 1 times the first times the second, plus the derivative of the second, e to the x, times the first, x, minus the derivative of e to the x, well, that's just e to the x, plus the derivative of c is just 0. So that was a terrible 0. 0. And we have 1 times e to the x plus e to the x times x. Well, that is that. So that's good. Minus e to the x. That cancels out with that. The 0 is gone. So we are set. This is the integral of that. That is what we basically proved. And yeah, that's it. There are, so when you're dealing with integrals, and it's a product, oftentimes this is a great way to go. But you should still be looking for, does substitution work? Does integration by parts work? Could I simplify this some way or another? We should be looking for all of that. That's number one. Number two, knowing which you should take the integral of, choosing what is u and what is v, is sometimes tricky. In general, 99.9% of the time, you should pick u in such a way that when you take its derivative, it simplifies and gets easier. And hopefully when you integrate the v, it doesn't get much, much more complex. And sometimes you might have to do it multiple times. So I'm not in any way saying this is easy. This is a little bit of guess and check, just like when we did use substitution the first few times. It felt like guess and check. It felt like, oh my goodness, I don't know, what am I going to pick, Mr. Lynch, and this and that. But then you got used to it and you realize, oh yeah, this isn't that bad. Same thing's going to happen here. You're going to pick a few. You're going to be frustrated. I might give you a little bit of advice, or you just try something else, okay? And so don't be afraid to try anything. Try something else. That is the key to this. I'm going to put one more example up. This one will just be an example. This one's kind of a sneaky example, but I just want you to realize, like, guessing and checking and trying and stuff is an important part of this. Okay, thanks. Good luck.